After watching this video, you'll be able to recognize the impact of cloud-native microservices on application design, describe stateless microservices, and compare monolithic and microservices architectures. To fully leverage DevOps, you need to think differently about application design. You need to be thinking about cloud-native microservices. This image shows an application that's designed as a collection of small microservices, each one of these services independent of the others. Each service a particular domain of the application. You have made gathered from the names and the services, this is a ride-sharing service. There are drivers and payments and trip management and notifications. These are all small services that are single-purpose based around a business domain. Notice the lines going from one service to the other. These are pointing to the REST APIs. No service is accessing another service's database. In fact, databases aren't even included in the picture. This is cloud-native design using microservices, a collection of stateless services. Cloud-native means born on the cloud, taking advantage of the horizontal scalability that the cloud has to offer. These services are following the guidelines set forth in the 12-Factor app, which describes how cloud-native applications should behave. This was first created back in 2011 by the Heroku team. Heroku is one of the first platforms as service implementations, and it paved the way for cloud-native platforms that we have today. Applications are designed as a collection of stateless microservices. Stateless doesn't mean the application doesn't have state. It means the services don't maintain the state, any hidden state, right? The state is persistent in a database. Each service maintains its own state in a separate database or persistent object store. Separation of state is important. If services were to share state, you wouldn't have microservices. You just have a distributed monolith. Resilience and horizontal scaling are achieved through deploying multiple instances, right? Once you break your application down into multiple independent services, you can scale them independently as needed. For example, I could scale up the notification service without scaling up the other services. This takes advantage of the seamless, endless horizontal scaling of the cloud platform. And instead of debugging and patching, failing instances are just killed and respawned. We often use the expression that instances are cattle, not pets. Don't get too attached to your instances. We scale them out as needed, and we scale them back when not needed. And once you break up that application into lots of little microservices, you need to leverage DevOps pipelines to help manage continuous delivery of these services. The term microservice was coined by Martin Fowler and James Lewis. They said, microservice architecture style is an approach to developing a single application as a suite of small services, each running in its own process. These are not just threads. These are full processes running independently and communicating with lightweight mechanisms, often an HTTP resource. We now use REST APIs, these lightweight mechanisms. Fowler and Lewis went on to say, these services are built around business capabilities and independently deployable by fully automated deployment machinery. You saw that each service in the rideshare application was built around a business capability, such as driver service or passenger service and notification service. These services are independently deployable. For example, I can upgrade the notification service without redeploying everything else. It's particularly important that microservices enable everything to be independently deployed. How does this work with a monolith compared to working with microservices? Suppose you have a monolith that has calculations, copy capabilities, and to-dos. When you deploy this application, you have to deploy all the components together. We can split those out into multiple instances of independent microservices. If I need to increase my capacity to perform calculations, I can scale out those 3 instances and maybe make 10. I would not have to scale out the to-dos or the copy capabilities. It's very important to be able to scale them independently to make the best use of cloud resources. Each microservice would have its own database where it's keeping track of its own state. I could deploy them independently and change the database independently. I would only need to change and coordinate with my team to accomplish this because other services are using REST APIs to communicate. They're not selecting over each other's tables in the database. Suppose I'm working on an e-commerce website, which is a monolith, and I want to change the customer table. I would probably need to coordinate with the people on the order team and the shipping team, right, to change this customer table because they depend on it for orders and shipping. With a microservice, there's no need to coordinate with other teams because you're simply calling my REST API. You don't care what my table looks like. You come in through the API, I could change from using SQL database to a NoSQL database, and you would never know. You ask for customer data, I give you customer data. That is the one difference between a monolith and microservice architecture. With microservices, each service is loosely coupled and communicates through a REST API. In this video, you learned cloud-native architecture is a collection of independently deployable microservices. Stateless microservices each maintain their own state in a separate database or persistent object store. Microservices are loosely coupled services designed for scalability and communicate with APIs.